Hey, this is Michael Hines, managing editor at naturalrefrigerants.com. I'm here at ATMO America 2024 with James Seabrook, president of Vitalis. And I have him here for a few minutes just to talk about the company. And I'd actually like to start with some recent big news. And that's the acquisition of Vitalis by the KKVB Group. It's the parent company of TEKO, for those who don't know.
Thanks, Michael. Yeah. In April of 2024, we both saw a fit to bring German engineering and a boatload of 20 years of CO2 experience to North America by leveraging TEKO's knowledge and partnering with Vitalis to deliver solutions for R744 in North America.
And can you just tell us a bit about those solutions?
TEKO has a really wide product range, anything down from their mini cubes of 3 kilowatts up to the G6 rack, which does 960 kilowatts, and everything in between. The commercial refrigeration, store cooler cabinet refrigeration, multi-stage, low temp and medium temp, and then also industrial, custom applications, chillers, heat reclaim, and heat pumps they're doing as well. And that paired really nicely with where Vitalis was already focused. So we were focusing on the industrial side of heat pumps, either air to water, water to water, water to air, any kind of combination of source and sink. And we see a really good alignment in the split of those products. So the Rocksta product focusing on commercial and industrial cooling, and then the CoolShift product line focusing on heat pump applications for district energy or commercial buildings or industrial applications.
Awesome. And with regard to these TEKO products, are they being shipped in from Germany? Are you building them yourself? What does that look like?
Yeah, the current plan is they're built in Kelowna. Depending on the type of project, unit numbers, TEKO has a huge manufacturing facility in Altenstadt, Germany. They have some really slick automated pipe bending equipment. So if the project made sense, then yeah, we'd potentially be shipping subcomponents over and then doing final assembly, pressure inspection, certification, all of that out of Kelowna and servicing North America.
Awesome. And can you tell us, do you have any orders for these yet? Is there any interest coming in that you're eager to fulfill?
Yeah, lots of interest. I think that's why we're here. I think one of the things that we heard in the market trends is that CO2 is growing, and it's growing in popularity. And Vitalis is currently building a number of units that service our internal products. So they service our extraction machines and our CO2 recovery systems. We're also in the process of assembling a very large heat pump, air source heat pump, and we're in the process of assembling a water-to-water heat pump. For refrigeration applications, we have our first couple of projects from the TEKO side starting in about 6 months.
Okay. And yeah, on the heat pump front, because you guys do some pretty large heat pumps for North America. We're talking, I think it's megawatts plus. And you were talking at the session just now about a 2.5 megawatt heat pump. Can you
That's
tell us
right.
more about that?
Yeah, so in actually last year at ATMO, I was connected with UBC, University of British Columbia. They're located in Kelowna, and they have a district energy system that's currently serviced by methane or natural gas boilers. So this project was initiated quite a while ago as a mechanism to decarbonize the university. So they've got a low carbon target for 2030, and this heat pump installation will reduce their annual emissions by about 900 tons per year and service almost 100% of the district energy system loop.
Wow. Are there any other universities that have contacted you that you've seen that might be a candidate for district heating in the future?
There are many universities
In Canada, the U.S. What are we talking?
in Canada that we're talking to. There's two nice things about working with universities. One is that they have district energy systems, which makes them ready to decarbonize very easily.
Real quick, why do they have those? Why are they on deck with district energy, so to speak?
Large square footage, high reliability, good cost effectiveness for delivering large amounts of heat and cool. The really cool part about the UBC project and our heat pump is that it is reversible. So in this district energy system, and I think you'll notice I called it energy instead of heating. So district heating and district energy are similar but different in the sense that our application here is an ambient loop. So we're circulating water at between 6 to 25 degrees, which means we have very good performance with CO2. That allows buildings that are in heating mode to absorb heat from the loop, and also buildings that are in cooling mode to reject heat into the loop. So you get a very efficient system where you're not wasting any heat.
Okay. So it sounds like you're carving out kind of a unique niche where it's, hey, we can provide these large heat pumps for district energy applications, but also, we have this product portfolio of CO2 systems for the commercial space, which, I don't know. Would you say there's some others like you out there, or is it kind of a unique space for Vitalis to be in with that combination in North America?
Yeah, in North America, a compression-based thermal cycle is the same. It kind of depends on what side of the machine you're looking at, if it's the cold side or the hot side. And as for competitors in North America, we heard earlier from other OEMs that are working in the space, but it's evolving, and ultimately the end users that we're looking for are the early adopters, and that's where we found a really nice fit with universities.
Okay, early adopters, if you're out there, I'm sure you are, please let James know what you're looking for. I'm sure he can help you if it's on the CO2 front. And unless you have anything else to add, I think we're good to go.
Yeah, absolutely. I'd say that if you're uncertain about whether your application's a good fit for decarbonization, for sure reach out and talk to us, because the application engineering is something that we're passionate about, and it's the first step in providing a really good solution to decarbonization, is understanding what the needs are and understanding the temperatures to make a recommendation on system, and then really get into the financial analysis of why decarbonization is not only great for the environment, but also great for economics of whatever your business is, whether it's heat recovery in an industrial application, or if it's converting from a gas burning system to an electrical heat source. The COP of refrigeration cycles or heat pump cycles outperform electric boilers. So there's a good economic case usually behind these decisions as well, not only just the environmental aspect.
All right. Thanks, folks, for watching.